Hi, everyone. Thank you for joining us for this third session of our Wallaroo.ai series, ML Workflow Automation. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We do seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. This session is recorded and will be available to view on demand within 24 to 48 hours on this channel. Which brings us to today's session. I'll turn it over to Gustavo for introductions.
Thanks, Anna. Hi, everybody. My name is Gustavo Cordido. I'm a cloud advocate here at Microsoft. I work with AI, and a lot of AI implies working with our partners. And today we're hosting Wallaroo AI as one of our partners, and they're going to be talking about ML workflows, and I think you'll find it really interesting. So without further ado, I'd like to introduce and let them introduce themselves, but I'll present Martin Balt and Jeff Will, who will be presenting and speaking on behalf of Wallaroo today.
Hey, Jeff. Hi, everyone. I'll go to my slide first. So, hi, everyone. So I'm Martin Bald, Senior Manager of Community. So I've been very fortunate. I've had over 2 decades in the tech industry, the bulk of that with Microsoft. And my last role before I left the company was in DevRel. And it was probably the most rewarding part of my career, where I got to work with smart tech people like yourselves that are joining us today. And also the folks like Gustavo that, looking at technology and how to use technology to solve some complex business problems and also use technology for social good. And so through that, I was fortunate enough to organize, run a bunch of, other activities such as hackathons, workshops, video channel content, documentation, etc., and proof of concepts in the AI and ML space with customers also. So I'm really happy to be here, and thank you very much for taking time out your day to spend with us on this Reactor event. We know there's a lot of things competing for your time, and we do appreciate that you chose to spend it here today with us. And hopefully we can go through and show you how you can take your deployed ML and AI models that are in production and help ease the pain of orchestration and managing those models from a central location. Jeff?
Thanks, Martin. And hi, everyone. It's great to be here with y'all. My name is Jeff Will. I'm a senior product manager at Wallaroo, and I focus on the model deployment and management areas of the product. So I'm here today to talk to you guys about how to automate just those things. I have a background in data products across industries like utilities, automotive, law, oil and gas. And one of the best things or most interesting things I like to talk about in the AI space is at my prior job delivering behavioral and energy usage insights. So this was the utility sector, but it created a win-win-win. So lower energy demand, reducing customer bills, and driving more renewable energy. So that is one of the things that I look forward to with what AI can do in the world and have a positive impact. So that's why I'm here.
Awesome. Thanks, Jeff. And what we'll do is, as Gustavo mentioned, we'll quickly go through a couple of slides here just to sort of level set and set ourselves up for the technical example that Jeff will go through with Gustavo. And so, I'll cover off who we are. We'll talk about, the challenges, the benefits of, understanding and orchestrating and automating your workflows in production, and also some of the use cases that you might apply this to, as if you're in that space of learning, or if you're in a company environment that are looking to deploy models into production. Well, first of all, Wallaroo.ai, like, who are we? And so essentially we are that AI production platform. We help you operationalize your ML models and get them into production. There's a great deal of effort goes into the experimentation, ideation, and testing phase. And when it comes to production, more often than not, unfortunately, companies struggle to get those models into production, but then also making sure that those models, once in production, are performing the way they were intended to. And how do you then have the visibility into the performance of the models, regardless of where they are? And so that's where the Wallaroo platform comes in. It runs on Azure as well as other major clouds. And also, if you're in the position of needing to run on a internal data center, you can run it as well. But most recently, in the last 6 months, we've taken the technology that runs in that cloud environment and we've pushed it out to edge and multi-cloud scenarios where you can run, deploy models, serve them, optimize them, and also observe them and orchestrate them from the edge locations. But then that decentralization doesn't mean that you lose control of your model management. You have centralized model operations. And so they're really trying to help companies over that hurdle of getting models into production, but then also make sure that they're sustainable and producing the outcomes that they were intended to. So that's who we are. And so what we're going to talk about today is that automation and orchestration. So let's level set that first. What is workload automation? And essentially, it helps companies and helps businesses and departments and groups manage and implement that production of ML and those pipelines and models that they've put into production. As I mentioned, there's a lot of effort and energy goes into creating these models and getting them into production. But once they're in production, it's not a case of, okay, we're done, we wash our hands and we can step away and it runs, perpetually and everything will be fine. It's very important to make sure, as I mentioned, that you keep those models, observed, that you make sure that those models are producing the outcomes that they're intended to. And not all models will run in a real-time or streaming manner. You might have models that are in a sort of batch, periodic, deployment framework as well. And so, being able to manage those, make sure that they're running, and also, impact the people that are managing those in the real sense. And so there's a couple of modes in which we orchestrate these models. And so, as I mentioned, you might have a scheduled or a batch instance. So you might have a model that has to run every Sunday night at midnight, in this time zone, and it runs, and then it sort of dehydrates itself. And so it's not using the resources and costing the company a lot more money than it should be doing. And so this scheduling through the automation orchestration allows you to implement that and not have to sort of care about the overhead or the manual processing of people having to actively put these into production. And so it just ensures that they are all orchestrated, that any of the downstream dependencies and data reliance between them are coordinated, again, from a centralized location. The other mode is an on-demand. And so you might have situations where you're not having a scheduled approach, but there might be a case where, hey, we have to run this model or these models in an ad hoc manner. And so it gives you that flexibility to, efficiently, cater to that, again, while not taking up a whole bunch of people's time and cycles that, are super valuable in, your day-to-day workspace. And so giving you that sort of quick and easy approach to make any changes and make any updates that you need. And so these themselves lend themselves into a number of different use cases. And so, regardless of what industry you're in, you might have the need for orchestrate your models for demand forecasting. And one example might be that we're seeing a lot more of the retail, especially in the travel industry. We're seeing dynamic pricing take more and more of a foothold in these industries. And so that demand forecasting models and managing those models lend itself to this orchestration. The other way is that you might have models that are running in real time or they're streaming, and so you don't have to stop and start those models and run them as you would for a batch mode. but there might be reports that you want to draw out for them. In the manufacturing case, you might have maintenance uptime reports. Financial services may have fraud or compliance reports that need to be pulled from those models as they're running in that streaming or real-time manner. The other use case is event simulation. And so in the retail context, again, you might have seasonal demands or seasonality that you need to take care of. And so there might be back to school models that you're running, or holiday season models, or certain promotional event models that are being run. And so that event simulation allows you to find out, okay, what will happen here, and will it perform the way we want it to? And so it gives you the opportunity there to simulate that, especially when it comes to something like entertainment, a big game launch, or movie streaming or something like that, where are we going to exceed the bandwidth of requests? Are people going to renew and subscribe via the promotions that we're running, and pay attention to those things? And so it really helps give you that feedback into the time that you put into creating those models. The other element is also churn modeling as well. And so again, also in a vein of that subscription scenario where, why are people abandoning their subscriptions? Why are people, why are we getting a surge of renewals? And so some of those models help you focus on, the client behaviors and your customers, so that you can retain that customer loyalty if you're in that space, and also model for how do we attract new customers as well, whether that be in a physical store location or even in an online commerce context as well. So those are some of the use cases. And so the challenges that folks face when they try to implement these models is just getting models into production can be a long, arduous process. And so getting the pipelines, getting the models provisioned, getting them in the right framework, getting them deployed on the resources that are optimal for that deployment is important. Also, as data scientists and ML engineers, you want to collaborate with the folks that are in DevOps and IT Ops, but you don't want to be a burden to them. They're busy enough on their own, managing all the other facets of the infrastructure and business. And so, as a data scientist and ML engineer, you understand that ML ops space. You understand how to create, deploy, maintain these models. And so it gives you that self-service efficiency with which you can manage that part of the AI production without having to lean on and be a burden to folks in the IT ops space. It also helps that collaboration and closing that feedback loop so that things can be more streamlined and you're driving efficiencies within the workplace as well. And so these are some of the benefits that you can achieve from looking at orchestrating and automating your models. You're not just going to have one or two models in production. You're going to have multiple. You might have tens or hundreds. In the case of edge deployments, you might have thousands of edge devices out there that are running models in different geographies and different environments. And so having a centralized model orchestration capability is super important. And so what we'll get a chance to see now is I'm going to hand it over to Jeff. And Jeff's going to walk us through a sort of real-world simulation. I talked about the travel industry and dynamic pricing, and so we'll get an opportunity to see what that might look like. But you can also take it into the context of some of those other use cases that I mentioned, and think okay, we can definitely use this for some of the challenges and inefficiencies that we have right now. Jeff.
Awesome. Thanks, Martin. And thank you to Gustavo, too, for co-hosting with me here. I want to show you guys how we can easily automate flexible and reusable ML workloads. So that is what I'm going to walk you through here. We developed this functionalities because we saw a gap in the market where practitioners are using tools that aren't meant to do the job, maybe notebooks and things, or using tools that are more complex and do things that they don't need knobs for. So we think this is a simple and streamlined way to get models that are in production or ready for production automated. So to set the stage, we're going to be looking at the use case of forecasting airline passenger ticket demand using the open source airline passenger dataset. And we've trained a TensorFlow LSTM time series model using that data for the purposes of this exercise. So I've got my notebook here over in Azure ML, and we are going to first just run our standard import commands. One of the important things I want to call out here is we are importing Wallaroo. So Wallaroo has an SDK that enable a lot of these commands that allow us to do this in a streamlined sort of way. So to give you guys an idea, though, I'm going to start out with what our forecast might look like. So I've got some plots here just to visualize for us of the historical observed data. This, again, is from the open source data set. And using our model, what does the next time step look like? So we've got the first time step, then we update week 2 and a second time step. We update again week 3 and a third time step. So the idea here is, I think you guys can easily see that this lends itself to an automated workload. We want to run it on a weekly basis to give us a prediction of what ticket demand looks like, so we can give that to downstream products or users so that they can make business decisions based on that. So otherwise, if we don't automate this, right, we'd have to do this, and many organizations do this as a manual task. So it makes everyone's life easier, whether that's practitioners or operations folks that will appreciate fewer errors and lower costs by having this be a structured process. So in this demo, I'm going to walk you through 3 parts of the process here. So the first one is, as you can see on the screen, upload and deployment. I'll walk you through how quickly we can get a model that's already been trained into production. Then we're going to need to set up external data connectors. In a real production process, you're going to want up-to-date data, right? So you need a way to grab that data from a data store somewhere and use that in the inferencing. And then we're also going to then set up the actual automation within Wallaroo, just one way to do that process. So to jump in here, I'm first going to connect to my Wallaroo client. This is just something we have to do, and I've already logged in, so it didn't prompt me for that. But then I'm going to set a workspace, which is essentially just the area that we want all of this to happen in. So we're going to create a model here, right? So I've set my framework to be TensorFlow. I've named my model. And I'm giving it a zip file of that model and making sure that Wallaroo knows the framework we're using is, in fact, TensorFlow.
And sorry, Jeff, and are you limited only to TensorFlow, or could you use other frameworks as well?
As of today, Wallaroo actually supports a bunch of different frameworks. Most of the popular ones, Onyx, PyTorch, sklearn, many Hugging Face pipelines. We saw TensorFlow, but also specifically Keras, and then XGBoost is the gamut we run today. Certainly, we are always expanding that offering depending on what people need to use in the product.
Awesome.
All right, so now that we've got our model uploaded into Wallaroo, I can actually create a pipeline, which again, I'm naming, and then we offer flexible configuration for that pipeline. So this is super important when you have models of different sizes or different requirements. You can set CPUs, you can set memory, you can also set GPUs, which we are not in this example. But then we can create the pipeline here, add our model, and then deploy it all in one command. So if I do that, this takes a little bit to run. It's actually faster since I've previously deployed this, but you'll see 3 seconds here. I think when I ran it to prep for the call, it took about 13 seconds. So you can see it's a pretty streamlined experience for the user to get a model that they've already validated all the way through into production and ready to inference, which is what I'm going to show you now. So
that's still pretty fast, honestly.
Yeah. No, it's one of the things I really love about the product, and I'm biased because I'm a product manager, but yeah, I really enjoy how quick that is. I can get in here and do testing and manage it all as a product person, even not necessarily as a full-fledged data scientist or MLE. So I am going to show you, as most people want to, I'm going to smoke test this real quick just to make sure everything's up and running. So I'm going to grab a sample data point from my sample data. In this case, my model is expecting the 3 previous time data points in order to inference. So these are scaled from the maximum down to whatever the actual data is from the sample data. And I'm going to convert it to a data frame because, again, that is what my model is expecting. And I'm going to run it in my pipeline with my pipeline name .infer. And we can see here quick results. Most of that's probably network time. And here's my inputs again that match my inputs up there and my scaled output. So we think that the demand will be 65% of max, essentially, for this next data point that we did. So the next piece of this, now that we've got our model and our pipeline working, good to go in production, we can set up our connection to the product data store. So in this example, I've got a connection. I'm registering Wallaroo. I'm calling it BigQuery batch storage, connecting to the BigQuery client, and giving it all the credentials it would need here in order to connect. So.
And I see you're using BigQuery, and yeah. I'm assuming, can you also integrate with other data sources or?
Yeah, so the data connection that we've got in Wallaroo, that concept facilitates any data connection in the cloud. And so obviously I'm in Azure here, but I'm connecting to a GCP data store. So yeah, you can do Azure, AWS, GCP. If there are other ones, certainly it should support it because the object is flexible enough to support all that.
And what about model repositories?
Oh, great question. So today we support integrations with MLflow registries, with more potentially coming down the road. But yeah, that's where we are today.
Awesome. And are there any dependencies on the DevOps or IT Ops side for this as well?
Oh, yeah. So in setting this up, most people in organizations don't have the keys to the kingdom necessarily when they're connecting to data stores. So DevOps or IT is going to need to give you the credentials. But then once they're saved and registered in Wallaroo, that is available to anyone in a particular workspace. So you can reuse this data connection across the workspaces, and the credentials could be saved in such a way, depending on how your org does it, to limit which tables you might have access to via a particular connection. So there is some access control that DevOps can still exercise over accessing data, which I think is important.
Yeah, that's awesome. And I don't know if I'm getting ahead of myself, but this is help with collaboration and sharing work then, given that.
I think so. I mean, it helps both on like the DevOps IT ops side, so they don't have to reshare the credentials with every individual member of the team. It's just once in the workspace, and then you can use it. And likewise, data connection, only one person needs to set that up, and then it's available for anyone to use, which I am skipping ahead a little bit, but that's also true of orchestrations. Orchestrations are in the workspace, models are in the workspace. So if you have standard things that get used across different use cases, you can just reuse those things. You don't have to duplicate them or version control right across multiple places. It's all just one thing there.
Awesome.
Yeah,
that's great.
All right. So this is my BigQuery client. So I can then send in a query here to BigQuery just to look at the data. And this is kind of what I was talking about. This is the raw form of the data where it's just a count of passengers, and we've scaled the input for our models. But just to give you an idea, this is what would come out of a BigQuery data connection. So now we've got our pipeline ready to inference, good to go. And then we are, we've got our data connection here too, sorry. But now I'm ready to set up my orchestration. So I actually want to ground us in what that construct looks like, because Wallaroo has a somewhat opinionated version of it, which we think is flexible and removes some of the complexity. But I want to walk through that. So Anna, if you will switch back to our slide deck real quick. Awesome. So when we are automating ML workloads, we have a construct called orchestration that contains one or more Python files. This Python file has everything you need to run your process. It could be processing code. It definitely has dependencies, any additional artifacts that might be required, but it then all gets packaged together, and we can use that to reference one or more pipelines. So orchestrations also allow you to, interestingly, inference through one pipeline. A pipeline can have one or more models, and take that output and feed it into a second pipeline. We've seen use cases from some of our customers where they might have a premium plan for some customers where they run it through pipeline 1 and they can get better data if they run it through pipeline 2 and model 2. So they stop at pipeline 1, they deposit the data, and anybody that's paid for the premium service runs through pipeline 2, but they can package that all in one orchestration. So super flexible. Depending on the use case, you can do a lot of things. And as I was just saying, these Python files can also refer to external data stores, both to and from. So you're not limited to the data store just being inputs. You can also grab whatever outputs throughout the process and send them and store them in the same different data store. Might be that you have a separate data store for downstream products that need it to be shaped a certain way, right? So the orchestration allows the user to figure out and construct it, configure it however they need to.
Yeah, it gives quite a lot of freedom. It's good.
Yeah. And so then we can run this in two ways, as Martin already alluded to. We can do on demand, which you definitely want to do when you're first putting it into an environment, smoke test it, that kind of thing. But you also might have use cases where inferences didn't show up like you expected one day, right? So you need to rerun, maybe you need to troubleshoot, and that on demand methodology is a great way to do that. But then in our use case here, we want to automate recurring runs of this orchestration. So the orchestration is already set up. We know it's working, and we're going to run it every week, let's say, because that is what we need in order to feed our inferences. So with that, I'm going to jump into what our orchestration looks like today. So Anna, if you will jump back to my screen, thank you. And I have switched over from my notebook to, this is the orchestration file. It is named main.py as we need it to be. And you'll see it does a lot of the same things that we already walked through on our notebook, which is the idea. This isn't that different. We've got importing Wallaroo. We've got some helper function definitions connecting to the client, workspace or arguments for all the things that we can parameterize, setting workspace all the way through to inferencing and grabbing data and all of that. So this main.py file is really the execution engine for our ongoing orchestration. So if I jump back to my notebook, we can see here that we've got an upload orchestration plan. All we need to do is send in the name and the zip file. So this zip file, which I've hidden over here, has all of these different files in it in order to power whatever I need to do for my orchestration. So it's not just the main.py requirements, as you might guess, has to do with dependencies, and we make sure that those dependencies are available on the machine that's running these orchestrations. And so I can show you that this orchestration has been uploaded, airline forecast. I uploaded it earlier today because it takes, on the order of 45 seconds or so to get something of this size, and it is ready to go.
The zip file also includes the data, right?
Say that again?
Does the zip file also include the data that you're sending?
So
I see there are passengers, the CSV there, so I'm just curious.
So, in this case, the orchestration is actually pulling the data from the CSV. So I've got like a load CSV in this particular orchestration. But if you're running production data, you're going to be running your data connection and your data. It's going to reference your production data.
Got it. Perfect.
So this was just a easy to orchestrate kind of thing, so that I didn't have to have a data store sitting out there.
Got it.
Yeah, so we can run this orchestration. So from here, I am going to do a run once. So this is our on-demand command. I can name this run, and then I can send in my arguments. And I talked about parameterization essentially, and some of the use cases that even Martin mentioned, where you might have a particular model that runs in different markets, geographic locations, different marketing channels, things like that. Those could all be parameters within one model. So one of the things that we've seen customers do with this is, instead of having 300 models, one customized for each location, it's actually able to train on all the data, and then you just parameterize the inputs on inferencing in order to support this. So now the management side becomes way easier, less error prone, more consistent across different regions and things. So way more of an operational management gain for sure. So with that, I'm going to trigger this command. And then I think this is a better experience. So I'm going to run over to our UI here. And I am looking at my workload. So I'm in my my workspace here that I called Airline Forecast Test. and I have my orchestration here, airline forecast. So if I click in here, I can see a couple different tasks. So you can see earlier today, I created a test run and a scheduled run, but this is the one we just ran today, and you can tell by the timestamp. And if I go over to task runs, we can see this forecast run just ran successfully, and I can look at logs, error logs. So success means we don't see anything here, but we can then check out, we can verify that this did in fact run and give us inference.
Sweet.
So the next piece of this, though, is doing a scheduled run, as you saw in the UI, but I can create a second one. And again, with these arguments, we can run the same thing repeatedly without having to touch it week on week. So I do that, and it is now scheduled. And if I pop back over to here, we can see that it is already ready to go. It is running on Sundays at 11 p.m. And that's when the next run is this coming Sunday, but it hasn't run yet, so it doesn't have a last run info. And if I want to stop these, I can just hit the stop button here, and it will end that that scheduled or the immediate task as well.
Got it. And you can also work with your tasks from the UI, which I can see there. So that's
Yeah.
good. You have flexibility there.
Yeah, the upload portion is SDK API, but once you have that construct, you can do everything through the UI, which might be easier for operational folks. That name and then the run once, run recurring, and any schedule here. The input here also, I forgot to mention in the notebook, is a cron style input. So not always familiar to everyone, but this one in particular, again, is 11 p.m. every Sunday on a weekly basis. And you can do any other number of scheduling opportunities, monthly, weekly, hourly, every minute, and pick the month or day that you want to run it on, as well as time in this case. So,
and the arguments that I see there, are those the ones that you passed from the
exactly
as well?
Yep.
Got it.
You can copy paste these things into that that input, and so you have all the same functionality when it comes to creating a task in the UI.
Got it.
So yeah, so with that, just to wrap back around, these are the same sorts of graphs, but I think it's easier to connect the dots now. You can see that we've got all this historical data. We take the next timestamp. Next week, we pull from our production data store, do the next time step, and likewise all the way through to the end. So this really helps in particular in managing infrastructure, because you can stagger when these jobs run. It makes efficient use for any resources, but especially if you're thinking about models with GPUs, you can stagger those runs so that you don't need as many GPU resources, or you have GPU resources, because we know that they are hard to come by these days.
Right. And I was about to ask, like, what happens if all the resources we're trying to use are already used? I guess you're kind of answering that already.
That's it. Yeah, no. So within our product, we offer auto scaling. So there's cloud auto scaling, but the product then sits on top of that to auto scale. So if we run out of CPUs or any other infrastructure, it will increase the size of that. So the orchestration won't necessarily run right at the time that it was triggered, because when it's triggered, auto scaling will say, oh, I don't have enough resources, let me scale up. So as soon as that is available, though, orchestration will run, and then auto scaling will also see, hey, I don't have that peak demand anymore, and scale back down. So it makes things easy to see, and you can then see where are my trigger points, because maybe I can levelize that workload because I don't need them to all run at the same time. So interesting things for whoever is managing infrastructure or trying to optimize on cost front to be able to do that.
Got it. That's awesome. I wanted to ask. I mean, I is that the end of the?
Yep, that's all we've got. Yep.
Yeah, I wanted to ask, like, what kind of scenarios? Because this is a really cool scenario that you showed us here with the passenger prediction. But what kind of other scenarios have you seen the Wallaroo like impacting positively, or like people being interested in? Because I can see this like expand across industries, honestly.
It absolutely does. I think there's so much, as Martin's use cases span industries. One of the cool ones, we have a customer in real estate who on a weekly basis, they're targeting their customers are people with rental properties. So they own like apartment buildings, right? And they have empty apartments, and they say, I want to fill a certain number of these. How can I spend my marketing dollars to fill them to a certain percent of them, and how much should I spend on each of my marketing channels? So they have a prediction model to say, if I have essentially, I have 30 empty units, I want to fill 20 of them, and I have $5,000 to spend on marketing, what is the best way for me to allocate that money? And the model gives them that. So I think that's a really, really cool use case for them to recur and automate, and have those parameterized inputs of like, how much do you want to spend? How many units are available this week? That kind of thing.
Yeah, that's awesome. That's awesome. And I guess the next thing I would like to ask is like, do you have a set of resources that people can like look into, try to give it a go, try it out?
We do, and I'm going to let Martin take that one, I think, though.
Definitely. Yeah, and if you can share the deck again, yeah, that would be great. And so, yeah, Gustavo, yeah, definitely what we have, and I guess, this is where, as Jeff talked about, orchestration and automation there, it's, we showed it from the context of our product, right? But essentially, those practices of managing those models in production, making sure that, they are producing, they're running when they're supposed to run, and just simplifying the ownership of, having like an AI production environment is super important. And so, we have a number of different ways in which you can continue to learn after this event and continue those skills in that space. We have on the Azure Marketplace, we've got the 9 AI sort of common use cases. These are free inference servers, so you just you could grab it, click get it now, and in a matter of minutes you've got an inference server up and running for different use cases, as I mentioned, like YOLO CV, FRCNN. We have Hugging Face summarizer models, etc. And we're coming out with a couple of different healthcare models as well. These are all, publicly available. And the other opportunity as well, if you want to keep learning, not just about, orchestration, but I think a couple of weeks ago, we covered observability, and before that we covered deploying and serving to the edge. And so we have that free community edition. That license doesn't expire, and so you can grab that. You can also, which is important, we have the capability now of installing the community edition into GitHub Codespaces. So GitHub Codespaces, if you have an account or if your company has an account, you get, I think it's around 60 free hours of free platform cloud consumption a month. And so it's a great way just to quickly set up if you don't have an environment, like an Azure account or a trial or something like that. So you can just use GitHub Codespaces and start playing with this. We have a number of tutorials on docs.wallaroo.com. And we also have hands-on workshops as well, where you have to fill in some of the code, to make these models work, for the different use cases and contexts. And so these are some of the vehicles in which you can continue to learn. I know, unfortunately, there's probably a lot of people out there right now, in our tech industry that are looking to reskill, looking for jobs and opportunities. And so we have these free resources if you want to take advantage of them. So I just quickly want to say, if there's no questions, quick shout out to Gustavo. Thank you very much for taking your time and presenting with us today. It was great to have you here, and hopefully we get an opportunity to work again in the future. Thanks to my colleague Jeff. Great demo as always, Jeff, and great examples and insight and depth into this orchestration component. And then also we've got a couple of colleagues that are helping answering questions. So we've got John Hanzarek, who does our docs. And so if you go to our doc site, you'll see some of the great fruits of his labor. And we've also got Bob Mady, who is one of our engineers in front of customers. And so, Bob's helping us out as well. But then also to the Reactor team, who, help us prep this, help us set up. There's a lot of work goes behind the scenes, and we really appreciate all their time and effort to help us be here, and as well as yourselves. As I mentioned, there's a lot of things competing for our time, and we do appreciate you spending some of that here today with us, and look forward to some more in the future. Thank you.
Thanks, Martin. It's been a pleasure to have you here. I mean, it was very thorough. I got to learn a lot about Wallaroo, and honestly, orchestration seems like an extremely useful tool. So I'm very happy that you both were here to present and share your knowledge and share the the wonders of the tool that you've been working on so hard on. So hopefully this helps out. And yeah, thank you very much for joining us here and coming to us to present.
Awesome. Thank you. Yeah, and look for the recording. I guess it'll be up in a couple of days on the Reactor and on the YouTube channel as well if you want to catch up. Thank you. Have a good day.
Thank you, everybody.
Bye-bye.
Thank you, everyone.